Thank you so much for joining this lesson. As we continue preparing for the Kcse 2025, I'd like to invite all of you to our lessons. Remember our November, December holiday programs here for the secondary school students and also for the junior school students. For these powerful programs, which are having the sciences, the languages, and mathematics, you can reach out to us through the number which is already attached here. The timetable is out. You can see how decent it is from Monday to Friday. You can also see the timelines for every lesson. So please join us and have an experience of very sophisticated teachers with their areas of learning. Even if you are in junior school, in the different learning areas, you shall meet very sophisticated teachers and facilitators. So kindly make an attempt of joining us. Our registration line is already here. So just liaise with us through 07 04 15 33 66. These meetings shall be via Google Meet. Google Meet is very interactive, transformative, impactful. There you can ask questions, you can respond to questions, among other benefits of that app. So kindly reach out to us and get to benefit from our serious programs. Let's continue with mathematics paper 2. When you follow through our channel very well, you discover that this predictive post-mock has already been uploaded in our channel. Partly, that is the section 1. So all this work is already uploaded there. All this has already been uploaded. And that's why in this section, we shall now proceed to the section 2 of this paper. So let's cooperate through the section 2 without wasting a lot of time, directly to number 17, whereby we are told that a team of 2 workers, L and M, are hired to tile a school hall. Worker L, working alone, can tile the hall in 10 hours. M takes 3 hours less than L to do the same job. Even before we go to the demand statements now, these are instructions. You know, every math question is usually divided into instructions part and the demand statement. Demand statement is what you are supposed to do with the information provided prior or later. The demand statement can come before the instruction statement. So let's know that every word problem should be subdivided into the instructions part and the demand statement part. So in the instructions part, there is something we can already analyze. Worker M takes 3 hours less. That means M takes 7 hours. So M takes, just to make your work easier, you start interpreting in advance. So instead of this, it takes 7 hours to do the same job. That's a similar interpretation. If you had been told 3 hours more, it means it would mean 13 hours. Look at part A now. Determine the time the 2 workers working together would take to complete the tiling. All right, let's look at the rate of work. The rate of M equals to the rate of L equals to, how do we get the rate of work when we are given the time taken to complete some piece of work? You first take the total time taken, then the reciprocal. So for M, it's a 7th. That's why M requires 7 hours. L takes 10 hours. So he works a 10th of the work in 1 hour. So these are the working rates per hour, or simply the working rates. So together, M and L in 1 hour as M covers a seventh of the hour, a seventh of the work when working together, L will cover a tenth of the same work, meaning that jointly or together, they shall cover the addition because one is covering a tenth, another one a seventh, giving us 17 out of 70 of the work. And that is within 1 hour. That is within 1 hour. So there is this concept of reciprocating or reciprocal to get the rate of work. If I tell you that there is some work that Teacher Boniface finishes in 3 hours, that should translate to the fact that within an hour, I'm working a third. If I take 2 hours to do something, then it means I'm working a half in every hour. So you take reciprocal of the time taken to get the working rate. Reciprocal of the time taken to give us the working rate. Now, for the two of them, the combined workers, if we have their working rate, then we can also get their total time taken. Time taken also becomes reciprocal. So time taken by the two gentlemen should now be 70 over 17 hours. Yeah, 70 over 17. And this is 4 and 2 over 17 hours. 4 and 2 out of 17 hours. That is now the time taken when the two are working together. So I hope we are together in the reciprocal concept of this particular topic. Now look at more instructions. On one day, they started work together. After 3 hours, look at that. M left and L continued alone and finished the job. Calculate the total time taken that day. This is now the thing. Together, in a 1 hour, they work 17 over 70, meaning for the 3 hours, before M left, we will take 17 over 70 multiplied by 3, because for every hour, they are working 17 over 70. Then, within 3 hours, these guys will have worked 51 out of 70 of the work, meaning that now the remaining work will be 51 out of 70 proportions have remained. So remaining proportions are 70 minus 51. And this gives us 19 proportions over 70. 19 proportions over 70 of the work. This is now what remains by the time M is leaving for L to be left alone to continue with the work. You see that? So now, what is the working rate of L? Because L is now remaining alone, and L works at a rate of 1 over 10. So we say that within 1 hour, L works 1 out of 10 of the work. What about the 19 over 70 fraction of this work, which has been left for him to work alone? It will be 19 over 70 times 1 divided by 1 over 10. To divide by 1 over 10 means to multiply by 10 over 1. To divide by 1 over 10 means to multiply by 10 over 1. So this gives us 2 hours and 5 over 7 hours. So this is the extra time that L shall remain working in order for him to complete the fraction of the work that he had been left with by M. So look at the total time now taken this particular day. We have the 3 hours that they worked together, and now L alone is working for an extra 2 and 5 out of 7, giving us 5 hours and 5 out of 7 of an hour. This is the total time taken this particular day. It's a very good question. It's a very good question on rates of work. So when you understand rates of work, you are good to go in mathematics paper 2, because this is something that you should expect either in paper 2 section 1 or in the section 2 of paper 2, or even in both sections of the same paper. Now look at part C. Later, the owner hired a third worker N who worked at the same rate as M. Working at the same rate as M, what does that translate to? 7 hours a day to finish the work. So this N now is working 7 hours also, just like M. When all three workers worked together, they completed the same tiling job in 2 hours, 40 minutes. If the total payment for the job was 24,030 Kenya shillings, find the amount paid to N, assuming payment is proportional to the work done. Right. You know, we are supposed now to talk about, you see the working, the work is going to take 2 hours. 2 hours and 40 minutes. Can we convert all that to hours so that we have the time in similar units? So this is 2 and 40 over 60. So that we have 2 and 2/3. I can even go further to make it an improper fraction. 2 and 2/3 becomes 8 over 3, right? Yeah, 8 over 3. Now with 8 over 3 is the total time. And now there are proportions here. There is now proportions here. So we can check now. We can check the hours that each worked. So we say the rate of work. We have the rate of work of N as 1 over 7, M 1 over 7, but L 1 over 10, meaning that combined, what is their rate? Combined rate N, M, and L. What's their working rate? Let's check. When they are working together, what's the rate of their work? What is the rate of their work? This gives me 27 over 70. 27 out of 70. So this is their working rate. 27 out of 70. Then why can't we say this? That 27 out of 70, which is the total working rate for the combined, 27 out of 70. This now attracted 24,030. What about N, whose working rate is 1 over 7? What amount shall go to a rate of 1 over 7? So 1 over 7 multiplied by 24,030 divided by 27 over 70, which is now times 70 over 27. Actually, this is now the deal. Let me check what we are getting here. 1 over 7 times 24,030 multiplied by 70 out of 27. This gives me 8900. Actually, if we were to continue like that, we would say that You know, that is who? That is N. Let me just continue with the question, though, you know, that is now where you get your mark. The third mark will go there. But now, assuming that we had been told to find for each, M, who works at the same rate, would also receive 8900, meaning that now L, who is working at a slower rate, shall receive the remaining. So when you multiply this by 2, then we take 24,030 and we subtract. I'm getting 6230. Actually, we would have gone direct to this. Yeah. So M and N shall receive equal amounts of money. Reason being, money is paid proportionally to the work done, and their working rate is the same. So M and N goes home with the same amount of money. So that's how the question is approached, the part C. Are we now looking at number 18? Oh, we are together at number 18. The table below shows this is a income tax, yeah, in a certain year, monthly taxable income, then the rates of taxation in Kenya shillings. You can see them, yeah, in Kenya shillings. Now, in that year, Mr. Nyikuri earned a basic salary of 39,200 Kenya shillings, medical allowance 2,400 Kenya shillings, a house allowance 10,000 Kenya shillings, commuter allowance 7,200 Kenya shillings, and a non-taxable hardship allowance of 12,000 Kenya shillings per month. Now, Mr. Nyikuri contributes 1.5% of his gross income every month for the Affordable Housing Levy Fund. This contribution is exempted from taxation. You see all these instructions? I told you every question has the instructions part. Every question has the instructions part, then the demand statements. So let's continue internalizing all these instruction part of the question. We are told that contribution is exempted from taxation. Now, he has life insurance policy for which he pays a premium of 4,500. He is also entitled to monthly personal relief of 1,400 and insurance relief of 15% of the premiums paid. The premium paid. Now we determine part 1, Mr. Nyikuri's monthly taxable income. So how do we get taxable income? We add basic salary plus all taxable allowances minus anything which is non-taxable. For example, being very specific with Mr. Nyikuri's case, he earned a basic salary of 39,200, that is taxable, plus 2400, that is taxable, plus house allowance 10,000, that is also taxable, plus, let me underline all the amounts that I put into account. Commuter allowance 7,200. Then we have a non-taxable hardship allowance. So this one is not taxed. So we shall not add it as taxable income. That one should not be added there. That one should not be added to that amount. So this is now what we are supposed to consider as taxable. Then there is something else that I want us to check very keenly. Very keenly. Mr. Nyikuri contributes 1.5% of his gross income made every month. Okay. Mr. Nyikuri contributes 1.5% of his gross income made every month for the affordable housing levy. For the affordable housing levy. So now, there is a certain contribution that he makes, and that amount is not taxed. So let us check that amount. Let us check that amount. It's going to be 15%. So let me first add this. We're going to have 39,200 plus 2400 plus 10,000 plus 7,200. This is giving me 58,800. Okay. So now we are saying this, every month, this guy is going to contribute 1.5 of his gross income. What is gross income? The taxable income, which is 58,800 plus any other income. So what is that other income? That other income is going to be the 12,000, which was not among the taxable income. So we add 12,000 like that. So here I'm getting 70,800. This is what we call now the gross income, everything that he ever gets. Now 1.5% of this becomes housing levy. And this one should be exempted from taxation. So we multiply by 1.5%, we get 1062. Now this amount is not taxed. So we shall subtract it here. 1062 subtracted. So 58,800 minus 1062. I'm getting 57,738. This is now what shall be taxed. This is now the taxable income. So that's how you are supposed to interpret such a question. It's very interesting. Very, very interesting. So I've first come up here to find what we are calling the gross income of Mr. Nyikuri, whereby it's everything taxable plus anything else that he gets, even if it's not exposed to taxation. Then after that now, we obtained the 1.5% of that particular figure now. So whatever we thought was now taxable income, there is part of it that doesn't go to taxation. And now we also subtract it. So this is now the figure that we shall be taxing. So we go to 57,730. We check the brackets here and you discover that we will tax up to the last bracket. So in the first bracket, we tax 12,200 at the rate of 10. So in the first bracket, 12,200 at the rate of 10%. Now this will give us 1220. After that, we go to the second bracket, whereby we subtract now. We subtract the previous limit, 27,200 minus 12,200. That gives us 15,000 exactly. So 15,000, this now should be taxed at the rate of 15%, and automatically it shall give us 2250. Then we proceed to the next bracket, this one, whereby we are supposed to take 42,200 minus 27,200. This gives us 15,000 once again. So 15,000, this should be multiplied at the rate of 20% according to that bracket. And this will automatically give us a tax of 3,000 in the third bracket. In the fourth bracket, we take 57,200 minus 42,200. That again gives us 15%, no, 15,000, sorry, at a rate of 25% tax. This takes us directly to 3750 tax in the fourth bracket. And now what goes to the last bracket is the taxable income, which we were supposed to fully tax, 57,738. Now we subtract the limit here. We have already taxed up to 57,200. So what amount remains untaxed? 538. This is what now remains untaxed, and it goes at the rate of 30. That's a 538 at the rate of 30%. This now gives us exactly 161.4. We can now add. When you add up, you get what you call gross tax. So gross tax is going to be 10,381. 0.40. That is the gross tax for Mr. Nyikuri. But what we need, the monthly tax paid, which means we are supposed to go to the specific tax. Now, once you get gross tax, you subtract what we call relief. This guy is enjoying what we call a personal relief of 1400 and also relief due to premiums paid to this particular insurance company. That's 15% of the premiums that he pays. So we first work out 15% of the premiums, 4500. So this second relief due to premiums is 15% of 4500, giving us exactly 675. So now we talk about 10,381.40 minus the two reliefs, personal relief and also 675, the premiums relief or the insurance relief. So now the net tax payable by Mr. Nyikuri, who is a friend of mine, should be 8306.40. This is now the net tax, or rather the payee. Can actually call it the payee. So at the end of it all, this is what Nyikuri will pay. This is what Nyikuri is going to pay. So can we together look at part B now? Let's look together at part B. The following deductions are also made from Mr. Nyikuri's gross salary. ELB loan repayment, 5,000. Bank loan repayment, 21,000. Aon Minet, that's a medical insurance company, 2,000. Then we also have SHA, the Social Health Authority, 2.75 of the gross income, and cooperative shares of 4,800 Kenya shillings determine Nyikuri's net pay that month. For you to get net pay, I want you to get this one very seriously. You're supposed to take somebody's gross income minus all deductions. Minus all deductions. So for us to get paid for Mr. Nyikuri, we get gross income. We computed gross income somewhere. 7,800. Okay. So 7,800. Then we subtract all the deductions. The first deduction is usually the payee. So what is the payee by Nyikuri? 8306.1. Then 0.4, sorry. Then we add any other deductions or anything else that he pays according to the instructions here. Before you forget, please get to the initial instructions and look at the premiums paid, 4,500. That's a deduction made apart from the payee. Other deductions follow according to instructions. we are having loan repayment 5,000. We are having that was ELB, then bank 21,000. Then something else that he pays, hey, will he become, what is he going to remain with? Surely 2,000, that is for minute. And now we are going to SHA. You know, SHA is 2.75% of the gross income. That means of 7,800. Let me first check that percentage. 7,800. This is exactly 1947. 1947, like that. So 7,800 minus all these deductions. And all these deductions are totaling to 48,615.40. All those are deductions. So at the end of the day, this gentleman, Mr. Nyikuri, actually is a very serious teacher of mine. He gave an example of himself, but the figures are also examples, not a real thing. It's a very wonderful teacher of mathematics. He's a great partner in the setting of home stretch prediction exams. So that's why the name is featuring here. But the figures are not real examples. So the Mr. Nyikuri now, used as an example here, this guy is going to get exactly 22,184.60. Somebody with a gross of 7,800 is now earning 22,184. Number 19, this is now trigonometry. Complete the table below for the functions. Y equals to the sine of 2x, and also y equals to the cosine of 2x plus 30, giving your answer to 2 decimal places. You're not supposed, there is what you call demand statements for every question, as I continue repeating, to 2 decimal places, special instructions about accuracies, special instructions. All right. So you're supposed to know one thing, that when you start now computing those values, you should be ensuring that you stick to the accuracy of 2DP. Even if some of the values, the examiner has already placed accuracies of 0, which is accuracies of whole numbers. You are not examining the examiner, but the examiner is evaluating you. Therefore, even if you get a whole number, please make it a 2DP value. I hope we are together in that. Ensure that even if it's a whole number, you make it 2 decimal places by including 0.00. So the sign of 2 multiplied by 30, because that's where we have a blank, and this gives us 0.87. 0.87, like that. At 90, we will talk about the sign of 2 multiplied by 90. This becomes 0. So you will not write a 0. You write 0.00, 2 decimal places. What about at 120? The sign of 2 multiplied by 120. Now this gives us negative 0.87. At 180, sign of 2 by 180. This gives us 0. So it's a 0.00. You can see another 0 next there. So at 240, sign of 2 by 240. That's just feeding into a calculator. 0.87. At 270, the sign of 2 multiplied by 270. Just using the calculator very well. 0.00. Yeah, 0.00. Then at 330, the sign of 2 by 330. This gives us negative 0.87. Yeah, negative 0.87, like that. Let's look now at the second function. Again, you utilize your calculator very well. Very well. At 60, that's why we have the first blank. So you will talk about the cosine of, if possible, just open the brackets. Now, what is 60 by 2? That becomes 120. What about when we add 30? 120 plus 30. Then this becomes, again, negative 0.87. Now we have the next blank at 150. So the cosine of, you open brackets. At 150, you multiply it by 2 first. 2 by x. So that becomes 300 plus 30, 330. Some of the things you can even compute without necessarily involving the calculator. And sometimes the calculator also gets tired. Please, let's learn to use our brains at some point. You don't have to multiply everything in the calculator. You know, there are some things where your brain is even more accurate and more efficient. As you type using your fingers, you might miss some buttons and multiply the wrong thing. But observing a few things like 180 by 2, surely, who doesn't know that this is 360? Then adding 30 to 360, that's 390. So we need cos 390 now. Why are you using a calculator, surely? So you now type cos. Cos 390. Look at 240. 240 multiplied by 2 is 480. So now we take 480 and we add 30. That's 510. So the cosine of now 510. This gives us a negative 0.87, like that. Then at 300, we can talk about 2 by 300. That's 600. So 630 now. So the cosine of 630, exactly 0. Will you write a 0? Not really. 0.00. Accuracy. At 360. 360 by 2 gives us 720. Then we add 30. That becomes 750. So the cosine of 750, 0.87. Wow. Those are the values. Now you have completed the table very well. Completed the table very well. And automatically now, the next question should be drawing now of the graph. So we are told, draw the graphs of y equals to the sine of 2x and also y equals to the cosine of 2x plus 30 on the same axis. On the same axis. So you just draw the Cartesian plane once. Cartesian plane should be drawn once. That should be drawn once. The x-axis also. You know, the x-axis is where we will put the degrees, which is now the values of x. It's now the x-axis. We are having the y-axis at this point. So now we can have some choice of scale. From 0, we can go to 0.5. So that now we have 1.0, 1.5, like that. Then on the other side, we can have the negatives now. 0.5, negative 1.0, negative 1.5, like that. I don't think we have values greater than that. Then now, we use the intervals of 30, which have been used in this particular, this particular table. 30, 60, 90, 120. So from 0, we go to 30, 60, 90, 120, 150, 180, 210, then 240, then to 70. Please confirm whether you are able to see clearly the values. You can see the stylus pen is almost drying up, but we are fixing it. Don't worry. We have 300 at that point. Then 330. Then after 330, can we talk about 360? After 360, we can have 390 like that. But now we are going up to 360 here. So those are enough values. At 30, we have 0 in the first curve. So let me plot the first curve only. Allow me use red to identify the coordinates of the first curve. So 30, 0. Or we can start with 0, 0, sorry. 0, 0. Then 30, 0.87. 30, 0.87. So you can use 0.9. Then at 60, 0.87, the same value. At 90, 0, 0. So at 90, we get back to the axis like that. 120, negative 0.89, which can fit at this point. At 150, the same value. Sorry for that. Sometimes the pen will just slide. At 150, at 180, we get back to 0. Then at 210, they had put a 0 there. I think this 0 can be confirmed now. Sine 420. It's not a 0. So it's also good for you to confirm their values. This is 0.87. Sorry for that. 0.87. At 240, 0.87 again. What about at 270? 0, 0. At 300, negative. At 300, negative 0.9 here. What about at 330? The same value being negative. Then finally at 360. So the sine of 720 is exactly 0. Yeah, exactly 0. So now you will allow me again say that here the value they would have put is 0. Sometimes just confirm their values. Once you are done plotting the values like that, it's good now you join them to come up with a very smooth curve. You will allow me introduce some different color so that people may see what exactly is happening. I'll also be mentioning something about these curves. When you look at a curve like this one, you shall discover a few things. Some of the things that you should be able to observe so openly is that at the topmost parts, the coordinates are not only one. We have a pair of coordinates there, meaning the turning point of the curve is a point in between the 2 points, a point in between them until you get the curve like that. So my point is here. Let's say you have a curve like this. That's a turning point. So it means when you join the dots, you will turn at the point which is there. But if points are like this, such that at the topmost, we have 2 coordinates then it means you don't turn in any of them. You turn somewhere between them. You turn somewhere between them. So I hope you've understood that concept. When you are negotiating the turning points, you check first, do we have an exact turning point of the curve? No. We have 2 points which are topmost. That means none of them is the turning point. None of them is the turning point. You turn somewhere between them and also at the lowest points. Just observe what I have done. At their lowest points, at the lowest points, I didn't turn at any of the points. I didn't turn at any of the points. You usually know that the turning point is somewhere between the two of them. Technically, you negotiate now the turning point. So it's none of them. But some other times, a curve will outline a very clear turning point. Now, for such a case, you will just follow it. So that's what you were supposed to do. And that's for the first curve. I think we can now name this curve. You can label it very keenly. The green curve is our first curve here. So I will name it as y equals to the sine of 2x degrees. The sine of 2x degrees like that. Let's go to the second curve now. We go to the second curve. I'm going to use black coordinates. Black coordinates. So I begin with at 0, we are having 0.8. At 30, we have 0. At 60, we have negative that value, sorry. At 90, negative, the same value. At 120, we are having a 0, or about at 150, positive 0.89. At 180, positive, the same value. At 210, get back to 0. Yeah, we get back to 0. At 240, we turn to the negative. At 270, also negative, the same value. What about at 300? We have 0, 0. Then at 330, that coordinate. And finally, that coordinate. So now we join them. Allow me now appreciate the red color by choosing it. The same technique is being applied for the second curve. We don't have a specific turning points. We don't have a specific turning points. And therefore, we negotiate the space between the two topmost and also the two bottommost. Like that. Let me check some of the corners here. Some of the topmost points here. I didn't negotiate very well. like that. So we have now the two curves plotted on the same axis, just as we had been instructed. So the red curve can also be labeled. The red curve is the curve y equals to the sine of 2x plus 30. Yeah, 2x plus 30. So our two curves have seriously been plotted. When you get graphical work, kindly don't hesitate. Please pocket the good marks and proceed. Look at part C of this. Use the graph to solve cosine of, that was cosine, not sine, sorry. This is supposed to be cosine. I just made a slight mistake in the labeling of the curves. Cosine 2x plus 30, like that. So when we respond to this now, this is a technical trap. The cosine of 2x plus 30, when you take this to the right hand side, it shall become positive because on the right hand side, we are just having 0, meaning that the first curve equals to the second curve. So you identify the points where the curves are meeting. The first point is between 0 and 30. So the values of x shall be 1, 15. The second point where they are meeting is exactly between 90 and 120. Between 90 and 120. So you take the average, that's 105. Another value of x where the two curves are interacting. That's exactly between, look at the curves, exactly between, this is the point. These are the points that I'm identifying. These are the points that I am identifying between 180 and 210. Exactly between those points, I'm getting 195. Then finally, we have another point of interaction between the curves here, exactly between 270 and 300. Is that not what we call 285? 285, like that. Then the last part of this, the 10th mark. The last mark now, which we are calling the 10th mark. State the period and amplitude of, we are told to state. You've not been even told by anyone using the graph, just stating the period and amplitude. You know, period is usually, okay, a general curve would take this and there will be a constant here. Then we have k multiplied by x, then plus or minus a certain acute angle there. We usually say when a curve is in this format, even when it's a cosine curve, actually this one has not been plotted here. This is just a general curve. So k, plus or minus a certain angle there. Remember, these two functions, any of them can be evaluated in paper 2, section 1. In such a case, you should know that the value just before cos or sine, A, gives us amplitude. That gives us amplitude. Then when we take 360 and we divide by the value of k, we get what we call period. Then when we take the absolute value of the angle added or subtracted there, we get what we call the phase angle. Phase angle, absolute value of theta. With this understanding, ladies and gentlemen, with this particular understanding, now you should allow me to proudly conclude that this curve stated here shall have period as 360 out of 2, which is 180 degrees. This is now period. The same will have amplitude as equal to 1 because the coefficient of sine is 1. And finally, phase angle of 30. for knowledge purposes, even though it's not part of the question. Phase angle is 30. So it's good for you to know how to state the three quantities and how you can relate them to the general equations of the trigonometric function. Look at number 20, ladies and gentlemen. This is on longitudes and latitudes. Longitudes and latitudes. An aeroplane moves at a constant speed of 268 knots, flies from town A, which is a 80 north, 84 north, then 10 in the westwards for 6.5 hours and reaches town B, which is 84 in the south. That should be a serious mistake. When you move westwards, you can't change from north to south unless you're moving downwards, which can be southwards. So the point here should be, okay, either these were both souths, yeah, you can change that one to south like that. Then it reaches B, which is also south here. Then X, calculate the value of X. You know, one interesting thing that we're supposed to know here is that we need the distance obtained first. And the distance is usually given by speed times time. We have a speed of 268, then 6.5 hours. What distance shall be covered here? And this distance should be in nautical miles, not in kilometers, because the speed already is directing us. It's in knots. So 268 multiplied by 6.5, we get a distance of 1742 nautical miles. Very specific, nautical miles. Okay, now proceeding with the question, you're supposed to know that because we are moving westwards, ladies and gentlemen, we are already in the west and we are moving westwards. That means we are going further to the west. Okay. We're supposed to know that distance in nautical miles when you move along the circle of a latitude, or rather a small circle, because moving westwards or eastwards, you're moving along a small circle along a latitude. In nautical miles should be given by 60 multiplied by the longitude difference, the longitude where A is to the longitude where town B is. That is the difference. Then cosine of the latitude where the two places are. So 1742, which is our already distance, should be given by 60 multiplied by non-alpha, cosine of a latitude of common latitude of 84, the latitude that hosts the two places. So alpha shall be, we divide this by 60, the cosine of 84, giving me exactly 277.8 degrees. So we will have a change of 277. Yeah, 277.8. Now, once you get that, you now ask yourself a very simple question. Just ask yourself a very simple question. You have the globe here. Let me state it. You have the globe there. Then we have the axis of the earth, or rather the prime meridian is here, 0 degrees. We have a 180 in the east, 180 in the west, like that. So when you move a complete lap from a point like this, like we are moving from 10, which is already in the west, 10, which is already in the west, that's the position of A, and we are still moving to the west. That's our direction of moving. So what angle difference, or through how many longitudes are we covering? 278 Actually, this can be rounded off to 278 degrees. So when you cover 278, where shall you be? Identifying the position. Therefore, from 180, when we subtract the 10, which is already there, we need only 170. Only 170, and we shall be at the farthest longitude in the west. So we add 70 here, we add 170 there, and we shall be at the end of west. So we start now continuing. We start moving, rotating, we start revolving. So now we approach the east side. When you finish all the longitudes in the west, you approach the east hemisphere, but now from the last degree of 180. So now you start now, you're making a corner like this. You're finished all the west longitudes, and now you start at 180 in the east. And now you want now to proceed again. You continue covering. You know you've covered 170 already, and you had 278. So with 278 and you've covered 170 already, what you've remained with for covering is only 108. What you've remained with for covering is 108. So now from 180, we subtract 108 and we get exactly 72. 72 in the east. So the value of x is 72 degrees in the east. The east is very important. Look at that interesting scenario. You moved towards the west, but you finally find yourself in the east, according to this particular spherical globe of the earth, because you covered all the west degrees. You are already at you are already at 10. So you only needed 70 to finish the west. But after you needed 170, so after covering the 170, now you start approaching the earth on the east side. But now you are starting with the farthest east, 180 in the east, and you have 108 to cover, which means you will come until you are appearing now from here. So you will come until 72. Until 72 in the east. So the value of x is 72. That's a technical question, and it really requires somebody who knows what they are doing. We check now part B. Part B of the same question. In part B, we are told that the plane turns and flies at the same speed along longitude. Along the longitude, okay, to town C. Town C is here. Therefore, remember, we are on the southern hemisphere. This is 84 in the south. Then what are we having? We're having B. Let me show you the position of B. So the position of B, that's a 72 in the east. Then we're having the position of B there. Now, this particular plane is going to move to town C. That means for you to flow to town C, you're going to move northwards until 34, still in the south. This is where C is now. So the plane is going to move now upwards. To move upwards means to move northwards. What are we finding? We are finding the distance between town B and C still in nautical miles. Therefore, this distance now along a great circle. Distance along a great circle in nautical miles. Along a great circle, along the circle of our longitude. Because from B to C, you should move along that longitude. which is now the longitude already identified as 72 in the east. All right. Yeah, as 72 in the east. And with that understanding, you'll be able to see that the distance is now 60 multiplied by beta. Beta is the latitude difference. So we just need 60 multiplied by, you subtract 84 and 34. We can even write it as part of the expression here. Is this 15? So we need 3,000 exactly, right? Nautical miles. That's the distance. Then now we find the total time it has taken to travel from A to C. Now, let's check from B to C first. From B to C, we need the speed. We need the distance out of speed. Speed was 268, if I'm not wrong. Let's check. Yeah, speed was 268 knots, meaning that the time taken from B to C, we need 3,000 out of 268, giving us 11 hours. 11 hours. Let me check the minutes here. At 11 minutes. Okay. 11 hours, 11 minutes. So total time, we were already having from A to B 6.5. A to B 6.5. So we add here. This is going to be, is it 17 hours? Then this is 41 minutes. Yeah. So 17 hours, 41 minutes. That becomes the total time taken. We can check at C. If the plane left A at 1300 hours, find the local time at C when it landed. So now we're going to consider a few things here. We shall consider a few things here. Let me plot the places. Remember, we are already having the positions identified. So we have 84 in the south, 84 in the south, then 34 still in the south, 34 still in the south. Okay. Then the position, there was a position which was 10 in the west. Which place was that? Which was that? Check something here. I don't know what's not displaying. Okay, we check whether it can write. Supposed to see it full screen. Okay. Yeah, here is the screen. All right. So now we have 10 in the west. Then now, after calculations, we discovered The other town here is 72 in the east. Okay. Yeah. So let me now label them. 82, 8410. 8410. That was A. This was A. This is now B. Then finally C is here. So that's now the journey. That's now the journey. But remember, moving from A to B was not along, was not just from A to B. It was now in the other direction. Instead of just connecting A and B the way we are seeing them, from A to B in the eastwards, now this particular pilot chose to move from A westwards and rotated the longer distance up to B. That's what he did. Anyway, our interest here is time. Our interest is time. Therefore, we should ask ourselves, what is the angle difference between A and B? From A and B, we have a time difference of from 10 west to 72 in the east. The angle difference there is 82. So we say 1 degree angle difference, usually 4 minutes time, meaning that when it's 82 degrees now, we expect 4 by 82. And of course, we divide by 60 to get in hours now. So 4 by 82 divided by 60. This now is going to be 5 hours and 7 over 15. 5 and 7 over 15 hours, making it 5 hours. Then this 7 out of 15 can be multiplied by 60 to give us 28 minutes. So we have 28 minutes there. So that is called time difference. And places in the longitudes, which are in the east, are ahead in time. Therefore, B and C are sharing time, and they are ahead of time of A. They are ahead of A in time by 5 hours, 28 minutes. So you will say this, from 1300, we are going to add 17 hours and 41 minutes to first get the time. That's the time taken according to this computation. Then after that, we shall be adding what we are calling time difference. 5 hours, because it's a place ahead in time. These are places ahead in time. Now, these are technical addition of time, because you will ask yourself, you can't add just like that, because this will give us more than 24. What you're supposed to do is ask yourself, with 1300, how much do you need? Because we can see 1741 and 5 hours 28. What are we getting first here? This is 4169, right? So we get 09 and we carry an hour. 18 plus 5 gives us 23. So we have 2309 hours. 23 hours, 9 minutes. So you ask ourselves, to 1300, how many hours should you add to 1300 to first finish that day? And you need 11 hours first. The day ends. So in the hours that you are supposed to add, which is 23 hours and 9 minutes, you first pick 11 hours, you add to 1300, you finish that day. You see? Then once that day is finished, ladies and gentlemen, once that day is finished, now this other day, how many hours have remained now for this hour day? When you subtract 11 from 23 now, you get 13. You remain with 1309 hours the following day. Actually, that's a very key thing, because now you've crossed to a different day, the following day. The following day. So we shall be continuing with the prediction of this paper later, because when you look at it, it's a very predictive paper. Yeah, you can see probability, you can see statistics, you can see now what you call a calculus here together with its applications. And you can also see something that we call linear programming. Very familiar concepts, yet predictive. Thank you for following. Remember our programs here. Remember to subscribe to Shifting Blades and also to share with your friends. Thank you.